All right, now it's time to solve this problem. And so, I'm going to do a free body diagram on the mass m right here. You can pick it anywhere you want, but I'm going to pick it right here. So the mass m is here. I have gravity acting on mg. I have a tension T going this way. Okay? Now what I'm going to do is I know that it's moving in the x direction. So I want one of my axes to be in that direction. So I'm going to make the x-axis be horizontal, because that's how the ball is moving in a horizontal circle. Notice I'm going to call this angle theta right here, okay? Which means this angle here is also theta, from alternate interior angles of a parallel lines, back from your geometry days. Well, then when I break this into components, let me change colors here, my tension is going to be T sine theta going this way, and T cosine theta going this way. All right. The first part is it asks for the tension. Well, I know from previously doing this problem that the tension is easily solved using the F net y. So I'm going to do F net y is equal to T cosine theta minus mg. But I know it's not accelerating the y direction, so this goes to 0. So I'm going to say that mg is equal to T cosine theta. They have to be equal to each other if it's not moving up or down. There's no acceleration. All right? And I want to solve for the tension, so I can say, oh, well, tension is just equal to mg over cosine theta. But if you remember the problem, I can't leave cosine theta. It has to be in terms of L and G. L and R, I mean. We already have the G and the M in here. So I got to get cosine theta in terms of L and R. But if I look, I have a right triangle right here. This is the hypotenuse, this is the opposite, and then this is the adjacent leg. I need to know what that adjacent leg is. But since it's a right triangle, I can just use the Pythagorean theorem and realize that this is the square root of L squared minus R squared. Square root of that. Because this is the hypotenuse, this is one of the legs. So this side is equal to that. Well, I can just say, oh, cosine theta then, cosine theta is equal to the adjacent over the hypotenuse. So the square root of L squared minus R squared over L. I'm going to plug that back into here. So this becomes T is equal to mg over the square root of L squared minus R squared over L. And how do I deal with complex fraction? Well, I take the bottom and I flip it and multiply, and this becomes equal to mg L over the square root of L squared minus R squared. That is the value you should get for the tension. All right, so that's part A. It's in terms of L, R, M, and G. Now we have to do part B. In part B, we're looking for omega. To find omega, we have to get the velocity, so we have to do F net x. So F net x is equal to negative T sine theta. But the ball is moving in a circle in the x direction, and at this point where we took the free body diagram, the centripetal acceleration is towards the left, so it's also negative. So this becomes minus mv squared over r is equal to minus T sine theta. Okay. And so the negatives go away. We can multiply by -1 both sides. And this becomes mv squared over r is equal to T sine theta. Now, you could plug in T here, but then you still have the sine theta, and it would get complicated. So I'm going to do it a little simpler. I'm going to take this T, the one that still has the cosine theta in, and plug that in. So I'm going to get mv squared over r is equal to mg sine theta over cosine theta. Notice that I can divide by m and the m's cancel out. And I get v squared over r is equal to g tangent of theta, because sine over cosine of theta is equal to tangent of theta. But I want to solve for omega. This is v, not omega. But I remember that v is equal to omega r, so v squared is equal to omega squared r squared. So I'm going to plug that in for v squared. So this becomes omega squared r squared over r is equal to g tangent of theta. This r cancels with one of those, so I get omega squared is equal to g tangent of theta, and then if I divide by that r, I get this. But I can't leave it like that because I got a tangent theta, and I need it in terms of L's and R's. So I go back to here, I got my theta, I can just do tangent theta. So tangent theta is opposite, so opposite is r over adjacent, which is the square root of L squared minus r squared. I'm going to plug that in for here. All right, so hopefully you can still see it over here. So omega squared, so I'm going up here. Omega squared is equal to g over r. Then for the tangent of theta, I'm plugging in r over square root of L squared minus r squared. Those r's cancel. And I take the square root and I get omega is equal to the square root of g over the square root of L squared minus r squared. And that's your answer for part B. For part C, you just plug in the numbers. You plug the numbers in here for t to get what t is, and you plug in the numbers for omega to get what omega is. And the answers you should get for part C is that t is equal to 5 newtons, and omega is equal to 30 revolutions per minute, or RPMs. And that's how you do number 47.